Welcome back once again. Hopefully you've gone and completed the lab on the table sets that we had previously from the previous module. We're going to move on now in Module 8. We're going to look again at something we looked at previously. Previously we looked at grouping using the group by clause. So we were able to aggregate the results of our query into groups using group by. We're going to extend that a little bit further and see how we could get different levels of aggregation and try and understand grouping sets and pivoting for summarizing the data values that we might get back from our query. So there's a fair amount of reporting involved in this module and a fair amount of aggregation, but hopefully it'll all become clear as we go through. So the module covers various different things. We're going to start with something called grouping sets. And we can declare our grouping sets, but we can also use another couple of techniques called rollup and cube to get automatically defined grouping sets. So we'll talk about those, and we'll talk about how we identify the groupings within the results. So which one's the grand total, which one's the subtotal, and so on. And then we'll switch gears a little bit and talk about something that's, I guess it's related in the sense that it's about summarizing data, but we'll talk about pivoting data and conversely unpivoting data. So there's a fair amount to get through in the module. Let's dive in and look at grouping sets. So grouping sets is an extension to the group by. It's a subclause that builds on the group by clause that we saw previously. And if you remember a group by query, effectively what it let us do was take one of the columns or multiple columns from the query and generate aggregated totals for each of those. So that seems pretty good. What would I want to do over and above that, Jeff, if I'm grouping my data?
Well, a simple thing might be grand total. So I'd like to have everything grouped up in a sum, but I want also to have the sum of the total, because we've seen we could do that. We left off group by initially, and we got the grand total, but I didn't get the detail.
Right.
So I want the grand total, I want maybe some subtotals, and I want at each level I'd like to have the information. So I want it in one query. Okay.
So the way that we can do that is we can use this grouping set subclause, and it lets me define multiple groupings, I guess, is the point. Rather than grouping by, one group by clause, even though there's multiple columns in there, I'm getting multiple levels of grouping if I do it this way, yeah? Mm-hmm. So there's a couple of things to look at in the syntax here. You can see it's group by grouping sets, and then I declare what are the grouping sets that I want to include. And those grouping sets can be based on columns, just like a group by statement. So each of these is its own group by that goes into here, into the grouping sets. And there's a special one. I can specify an empty parenthesis to say, give me the grand total, aggregate all of the rows and give me a grand total using that. So using that technique, I can define effectively multiple group by clauses in the one query. So here's a kind of worked example on the slide to help us kind of understand what's going on here. I've got my employee ID, my customer ID, the sum of the amount as the total amount from my sales orders. So it's a fairly straightforward query where I'm looking at effectively getting the sum total that each customer and employee has placed in an order. But what I want to do is I want to also get the groupings to show me for each employee what's their total, how much revenue has each employee brought in, and show me for each customer how much revenue has that customer spent with me in total, regardless of which employee sold them the details.
But all in the same query.
But all in the one query. And then finally give me a grand total of the total amount of sales across all customers and all employees. So I'm able to define those three different groupings within the one query using these grouping sets. So here's what the results would look like from that query, and you'll see there's a number of nulls in there. The first row where I've got a null for employee ID and a null for customer ID, well, which of our grouping sets do you think that might be?
Well, if we don't have a specific customer or a specific employee, is that everyone?
Bingo, that's the total for all sales, yeah? So that you'll get one back that has a null in all of the columns that we've got in the query, and it'll just give me a grand total for the total amount of revenue that we've generated. As you can see, we've done startlingly well and generated 256.23. So the next one down has customer IDs and no employee IDs. So we would assume
Well, then with a subtotal for each customer, I guess.
Yeah, exactly. So what we've got there is the subtotal is generated, and that's that customer ID clause that I've got in my grouping sets. And then the last one that we can see there, obviously, is the only one remaining. That's the subtotal for each employee that's coming out of there. So I've got those 3 different grouping sets that I've defined. I've got customer ID, I've got employee ID, and I've got a grand total at the top. So pretty good, pretty useful. The syntax is a little bit complex to kind of get your head around. And to make life a little bit easier, there are kind of common themes that people use when they're grouping data. So there are a couple of built-in operators that will automatically define the right groupings for you. So the first of those that we want to look at is something called rollup. And rollup is a really common thing to want to do where you have perhaps a hierarchy of things, maybe products and product categories and product parent categories, or maybe you have states that are in cities that are in state provinces and state provinces that are in country or regions. So you've got that hierarchy of things and you want to group at each level. Rollup's really useful for that. And what it will do is give me a grand total and subtotals at each of the different levels. Mm-hmm. And then cube is actually even more combinations. It actually gives me every possible combination of grouping set that I would need with that data. So as a shorthand to say, just show me every possible aggregation here, I can just use cube to go and get that result back.
So in that one there, where you've got salesperson and customer, you'd get the totals for each salesperson and the totals for each customer, and then also
the total for each salesperson and each customer combined. Yeah, so every combination coming back out. So you might have spotted the potential flaw in all of this.
You had null values in there. Mm-hmm. So if we've got a null specifying our grand total, and we've got a null specifying our subtotal, what is in there to say, well, we have some nulls as well? Because I have some web sales and they don't have no employee sold them.
Right.
So they have null.
Yeah. And that's part of the problem. The first thing is, obviously, if you've got multiple grouping sets, in those rows, I told you on the slides, I basically told you, but we had to sort of look carefully to see, well, it's got a customer ID but not an employee ID, to figure out which of the subtotals we were seeing there. And then secondly, as you say, if I've got nulls, well, it might be because there's been an aggregation created and null goes in the column that's not part of the aggregation. Or it might be because the original data was null, and I have a null employee ID or a null category or whatever it might be. So there is potential confusion in identifying, well, where did this row in the result set come from? Is it part of the original data, or is it an aggregation? And if it's an aggregation, at which level is that aggregation? So to help us deal with that, there is actually a function, a grouping ID function, which you specify in the query, just like it's a column, and that column will indicate which grouping comes. Well, actually, I say it will indicate what happens is it's a grouping ID function, and you pass in the name of the different groupings you've got, and it will give you a 1 or a 0 to tell you if this row was returned as a result of that grouping or not.
So then we could filter to find our grand total, because it's going to have, it's summarising on both of those columns in this situation, and that's our grand total, or if it's on one of the columns, that's our subtotal. And
exactly, yeah. So for each possible row, each possible column I've got that I might be grouping on, I can use the grouping ID function to give me a 1 or a 0 to say, is this row grouped on this function or not? Let's look at an example of grouping data using the various different options that we have. And I've commented out some of the options down here, and I'll switch them around as we go through. But let's start with something that should be familiar to us, just a basic group by. I'm getting the product category name, the parent product category name, which will be the high-level category like bikes or components or whatever. I'm then getting the category name, which you can think of as being the subcategory of bike or the subcategory of components, or mountain bikes or whatever, and then a count of the number of products that there are in that subcategory. Then getting that data out, and I'm, in this case, just grouping by the product category name, the parent product category name, and the product category name. So if I run that query, I get back what I would expect. I get my parent product category accessories, the product category within that, bike racks, and the number of products that there are that fit that particular grouping. And again, within accessories, bottles and cages, there are 3 products that are within that particular category. And that works all the way down. I can count them out.
But we don't know how much we sold in accessories.
Well, we don't know how many products we have in accessories in
Agreed.
total unless we add all these things up.
And the grand total, we'd have to add them all up.
Yeah. So we have no grand total. And I have no way of knowing. I mean, there's also a possibility here that I might have bike racks that are in accessories, but bike racks might also be in another category. They might be in components as well. So there might be some bike racks that are accessories, some bike racks that are components. And what I don't have is something here that says, well, yeah, how many bike racks do I have regardless of which category they're in? Mm-hmm. So I don't have every possible combination, but I have what I asked for in the group by. Instead of grouping by those individual columns, what I'm going to do is use the next option here, where I'm grouping by grouping sets, and I'm going to create grouping sets based on the parent product category name and the product category name and a grand total. So I'm using that parenthesis option there. So if I go ahead and run that, I'll start to see some nulls appear. And what I'm getting here is the grand total across the top. So there are 295 products all told in my catalog. And then within my bib shorts, regardless of the parent category, I've got 3 things that are bib shorts. I've got 3 things that are bottles and cages. And if I just move this up a little bit to make it clearer what's going on, and scroll down, I can see a whole bunch of nulls here. So each individual product category name, I get a total count for that. And then it switches across and I get totals for how many accessories I've got, how many bikes, how much clothing, how many components. So that's pretty good. It's given me some of what I was missing just from the basic group by.
And you've lost the combination of product category name with product parent.
Exactly. So I don't know for sure, out of these 3 crank sets, which parent product category do they come from? Is that one parent product category, or are there 2 crank sets in components and 1 crank set in accessories, or whatever? I'm not getting that level of detail. Now I could get that. I could manipulate the grouping sets clause here and have more sophisticated subclauses within there and get back every combination. But that becomes quite complex to write. I actually have to think through a lot of different combinations. It is highly customizable, which is great. But if all I want to do is say, look, I just want to roll up by my product categories, I can use the built-in roll-up option instead. So I'm rolling up by product category name and by parent product category name and by product category name. So I run that. And that gives me my grand total at the top. And then for accessories in total, there are 29. And then within accessories, that 29 is made up of 1 bike rack, 1 stand, 3 bottles and cages, and so on. So I'm getting that additional level of detail. Now, again, what I'm perhaps not getting here is that level of detail. Well, okay, you've given me a total for accessories, but you haven't given me a total for bike racks that might, well, there's only 1 bike rack. You haven't given me a total for bottles and cages if there are bottles and cages in different parent categories. So I want to see the total of bottles and cages regardless of the parent category. So again, there are some aggregations we're not getting. And to get that, I could actually use cube, which will just, effectively what I'm saying is, look, just aggregate these every way they can be aggregated and give me back get back the results. So if I run that, I get a grand total. I get a total of bib shorts regardless of the parent category, and a total of bottles and cages and so on. Again, we'll just move this up a bit. Then I get a total for accessories, and then within accessories, I get the totals of the individual product categories. So it's effectively slicing and dicing it every way that it can to give me every possible combination and every possible total. So that's a use of grouping sets. I guess the main point is that the grouping sets clause itself, you can define exactly what you want. But the downside of that is you have to define exactly what you want, and it can be fairly complex syntax. As a shortcut to fairly commonly accessed aggregations, you can use roll-up, or if you want to get every possible aggregation, you can use cube, and that will bring you back that data. So grouping sets and the cube and roll-up operator, really useful for getting those different levels of aggregation. We're going to look at another form of summarizing data, but this is slightly different. We're going to look at pivoting data. And as its name suggests, what we're doing is taking data from a row-based orientation where we've got rows of data that perhaps shows me each sale with its product category of what it is that we bought, and then I'm pivoting that to a column-based orientation where I can actually get totals of how many sales were there for that category, or how many sales were there for that product, or whatever it might be. So conceptually, this is, you can see the diagram there. I've got distinct values from a single column projected across as headings in the other column. So where I've got values of category over here, like accessories and so on, what I've done is I've pivoted that across so that those values become the column headings, bike, accessories, and clothing, and I'm getting a summarized amount of revenue within each of those categories across each order ID.
So it looks a bit like a spreadsheet.
It's very like a spreadsheet. It's a pivot table that you would have in something like Excel. And I guess that's an important point. The reality is this technique is really useful in environments where perhaps you as the database developer or database manager are responsible for creating reports that people want, pivoted, summarized reports of data, where they don't themselves have any wherewithal to create those reports, or don't have the necessary permissions, or you want to very strictly control the reports that they get. The reality is, in most, certainly most modern organizations, users who need this type of data probably have something like Excel, and they can get the source data themselves and then pivot it and do whatever they want to do with that to aggregate it. So while this is useful if you are actually needing to generate those reports in Transact SQL, the reality is a lot of reporting tools and client tools will actually do this this kind of thing for you, and you just provide the source data. But with that said, here's the syntax that we can use to pivot that data across into those columns, and it can be a useful way to generate those types of aggregated report. Now the converse of that, having pivoted the data, the obvious question is, well, can I get it back to how it was? Can I unpivot it? And there's kind of a qualified yes is the answer to that. To a certain extent, I can get it back in the sense that I can, re-rotate the data back from being pivoted with those columns back to being row-based. That's fine. And it will split or spread the values from the row source across into the target rows. But there is a problem that when I do that, you can see I've pivoted back across. I've got the order ID, I've got the bikes, I've got the value coming across there from my table here. So in this case, I've got pretty much what I needed to get back from there. But I may lose some detail. Because I've aggregated when I did the pivot in the first place, I might lose some data when I unpivot it back, because I might lose some of those aggregations.
So you've just got the same numbers on the right that you had on the left, whereas when we did it originally, you actually had...
I actually summed up, so we brought back, across those order IDs, I've got the values for each individual category. If we go back to how it was before we pivoted it, I had the product IDs in there, and I had details for each order ID. There was two different products in order ID here, where I had bikes and accessories, and actually in order number 25, I had some accessories, but I had two products that were in clothing, one at 26.57, one at 5.78. So I got, I had that level of detail for each individual line item of clothing. I got a total. When we unpivoted that back for order 1025, all I know is there was a total of 32.35 spent on clothing. I don't get the further breakdown into the individual line items.
So if you can't see it in the pivoted data,
you can't get it back.
Unpivot it,
exactly. So that's the consideration you've got. Yes, you can pivot data and you can unpivot it to kind of get it back again, but you may lose some levels of detail. You may lose the detail rows if you've aggregated multiple rows when you pivoted in the first place. So let's take a look at using pivot to pivot some data. And what I'm doing is I'm querying my AdventureWorks LT database, where I've got a number of products which are categorized into different categories, and those products may or may not be colored. So if they have a color, if they're red or blue or yellow or whatever, I want to see what the color is. If there is no color, then it's null, so I want to see it as uncolored. So I'm effectively just seeing which color my different products are and which categories they're in. And that's defined in this subquery here, which creates a derived table effectively. So if I go ahead and run that, I can see for each product ID what category it's in and what color it is. So I can get across here that various different products that are mountain bikes that are silver, and some of them are mountain bikes that are black, and so on through the different colors. So, well, that's pretty useful, but what I want to do is actually count them up. I want to know how many mountain bikes do I have that are yellow and how many mountain bikes do I have that are red, and whatever it might be. So I'm going to pivot these values here, the different category names. I'm going to pivot the colors, the yellow color, the red color, whatever, as columns. So I'm going to pivot that across and have columns for each color, and then a count of the number of products that there are in each of those colors for each category. So each row will be a category.
You're actually defining the colors you're expecting to see in code there. So you know that there's red, blue, black, silver, yellow, grey.
Exactly. So I have to know the data. I have to know what columns I want to create using the pivot statement, and that's going to come from this source data. So at some future point, if we started selling a green bike and I don't have a color for green, then it's going to be missed out of this. I'm not going to see it when I pivot the data.
The query would work, but
the query would work. It just would lose the green bikes. Yeah.
Okay.
So if I go ahead and run that select, including the pivot clause at the bottom, we're pivoting the color, pivoting a count of the product ID for each color in those different color categories. If I go ahead and run it, what I get is the category name, so I've got a row for each category, and a count of the different products that are different colors in that category. So in this case, there's 3 multicolored bib shorts. There are 2 silver brakes. And it gets a little more interesting if I just bring this up a bit and scroll down a bit further. We start to get to a point where there are 16 black mountain bikes and 16 silver mountain bikes, and there are 20 red road bikes and 14 black road bikes. So I start to see those counts of the different products across the different colors. So I've pivoted across, and that might be what I want from my report. Now, of course, what I could do with those results is I might go and I could create a view based on this, or I could create a table based on that. So I could actually go ahead and create a table called product color pivots and go and stick these values into that table. So I'll go define that table and then use exactly the same statement we just saw to insert data into this temporary table. So there's 37 rows now. I've effectively archived that off as a report that I can use again and again.
So we've got some data in from someone that's already been pivoted.
Yes.
But we don't want it that way around. We like to change the orientation.
Yeah, and that's actually a more realistic example. Typically what happens is you don't run a pivot against your own data and then store that pivot somewhere unless you need it for a report. But what you might do is get data in that you're importing from elsewhere that's already been pivoted, and you want to switch it around into a more detailed view where you're getting it unpivoted. So in this case, we'll imagine that's happened, and what I want to do is to unpivot that data so that I can get the different product categories and the colors and the counts across that way. So if I run that unpivot statement, sure enough, I get back those product counts. I've no longer got columns for each color. I've just got a color column that has the different values in it because I unpivoted the product count value for color and then specified this is what's in the source data. I want all of these values to end up in a column called color.
And so if we've got individual products in there, could we get back the product ID?
No, and that's something we discussed in the slides as well, is what you can't do, if you've pivoted the data originally from source data and in doing so you've aggregated it. So for example, if we look at my original query, which was here, actually I could do it from there. There's my source data. I had a product ID associated with each product, and then I had the category and I had the color. I then pivoted that to count the product IDs. Now, I've just reinserted that in the same table. But that meant then that when I unpivoted it, which probably won't work now. Well, yeah, it still works. When I unpivot it, I don't get the product ID back because I counted that. What I've got is a count of product IDs that I can never get back to that source data again. So you will lose the detail if you pivot and then unpivot back. What it's letting me do, though, is to take aggregations that are currently displayed across multiple columns, each one representing a different color, and bringing them into just simply having a color column that has the values in them.
So someone gives you a load of data and you just think, well, that doesn't work, it's the wrong way around. We can still deal with that.
Yeah. So we've covered a lot of ways of aggregating and grouping our data and summarizing it in this module. We looked at grouping sets, where I can explicitly say how I want the different groupings to behave and the different levels of aggregation. We looked at rollup and cube, which are built-in grouping sets effectively that I can use to get summarized data. And we looked at how we would go about identifying the different groupings that I have in the results. And then we looked at pivoting data and unpivoting data. So taking data that has values in there that I could aggregate and switching what are values in one column across to be multiple columns with the aggregations in each column, and then unpivoting it back to the kind of row format. So you'll get a chance to experiment with this in the lab. So as usual, as for all of the modules in this course, download the lab documents and the lab files, use the Getting Started guide to get yourself set up in Azure SQL Database, and use the lab to challenge yourself to learn a little bit more about using the syntax here. And when you're comfortable with grouping and pivoting data, you're ready to come back and join us for the next module, in which we'll start looking at not only how do we query data, but how do we update data in tables and insert new data into tables and delete data from tables. So join us back for that when you're ready.